So this video we'll see about mass spectrophotometry. It is also called as mass spectroscopy. So what is this mass spectroscopy? So this mass spectroscopy is the most accurate method. It is the most accurate method for determining the molecular mass of the compound plus its elemental composition. How am I going to find the mass of the compound? So I'll be taking a molecule. So I have a neutral molecule. So this neutral molecule is bombarded. This neutral molecule is bombarded with a beam of electrons. So I am going to bombard this neutral molecule with a beam of electrons. So when this molecule is bombarded with a beam of electrons, what happens? Because of this bombardment of the electrons with this molecule, an outermost electron will be kicked off from this molecule. Okay, so this beam of electrons, it is going to remove one electron from this molecule and it results in the formation of molecular ion M plus. Along with it, the electron beam which is hitting the molecule will also be ejected, plus the electron which is removed from the molecule will also be coming out. Since one electron is removed from this paired electron, you will have an lone electron here. So that is denoted by this dot. So your molecular ion along with this one electron, unpaired electron, will be appearing. Now, so each kind of ion, it has its own mass to charge ratio. It has its own mass to charge ratio. So that is M by Z, or it is denoted by M by E. So based upon this mass to charge ratio, I can find the molecular mass of the given compound. I can find the molecular mass of the given compound Okay, suppose now this charge, what is this charge? So this is the charge which is obtained by this molecule. So in most cases the charge will be plus 1, hence M by is E value or M by Z value will be equal to the molecular mass of the compound. It will be equal to the molecular mass of the compound. So I'll repeat. So your mass spectroscopy or mass spectrometry, it is the most accurate method for determining the molecular mass of the compound along with its elemental composition. So how am I going to determine the molecular mass of my compound? So I have a neutral molecule. Remember, this is my neutral molecule. So this neutral molecule is bombarded with a beam of electrons. That is, one electron from the beam of electron is going to hit this molecule. So when it is going to hit the molecule, what happens? It removes one electron from its outermost shell. So remember, the electron in this molecule is always paired, right? So it is going to remove one of the electron from that electron pair, so that it results in the formation of ion, molecular ion. So you call this as the molecular ion. It is also called as parent ion. So along with this molecular ion or parent ion, the electron which is going to hit the molecule will also come out, and the electron which is ejected, which is produced from this molecule, will also be coming out. Now we'll know if it is a compound, we'll know what is the molecular mass of this M. So based upon this mass and the charge which it is carrying. We can find out the molecular mass of the given compound. So with the mass to charge ratio, we can find the molecular mass of the compound. Almost for all the molecular ions, the charge will be positive one. Hence in all cases, almost in all cases, m by e, that is mass to charge ratio, will be equal to the molecular mass of your compound, right? Now I said you that this molecule, when it is getting bombarded with the electron beam, right? When it is getting bombarded with the electron beam, what happens? Along with the electron removal, so along with the electron removal, some amount of energy will also be liberated. Some amount of energy will also be liberated. So what happens? Because of this energy, the m, it will be getting excited to the excited level. It goes to the excited level, and it will be representing there as m plus ion, and it will be represented as m plus ion, since because with the electron removal from this molecule, energy is liberated, and it is going, the energy liberated will kick off your molecule. It will promote the molecule, neutral molecule, from the ground state to the excited state as molecular ion. So we know very well that the excited level is always an unstable one. The excited level is always an unstable one. So what happens? So this m plus molecular ion, it has one positive charge and it has a free radical. So what happens? Since this excited level is an unstable one, it tends to return to the ground state by undergoing further fragmentation. So it either yields m1 plus m2, or it can either yield two combinations, where m1 will carry your positive charge and m2 will be your free radical, or m1 will be the free radical and m2 will be carrying your positive charge. You see here also the positive charge, the charge with the ions formed is +1. So the molecular mass by mass to charge ratio for m1 and m2 will be the molecular mass of m1 and m2. So these free radicals are not deducted in your mass spectrophotometry. They are not deducted in mass spectrophotometry. That is, they are removed out by using the vacuum pump. Only this m1 and m2, they will be reaching your detector based upon their mass to charge ratio. They will be recorded in the detector based on their mass to charge ratio, right? So we'll see how this process is formed here, how this molecular ion is getting bombarded with an electron beam, how the electron is removed, how it is going, how it is accelerated towards the detector. We'll see an basic component of a spectrophotometer. The main condition for mass spectrometry is your sample must be in the gaseous phase. So now I have my vaporized sample. So I am having my vaporized sample. Here. So this vaporized sample is let into the ionization chamber. It is let into the ionization chamber, and you will be having accelerators. That is, which is going to accelerate the movement of your molecular ion plus the electrons. Okay. So here in this ionization, what happens? You will have either gas phase ionization or desorption ionization. So based upon the type of ionization, so this area ionization technique will be different. So now let us have an electron beam is here. So my vaporized sample, when it is introduced into this ionization chamber, what happens? It undergoes ionization to form m plus ion along with an free radical. So that is accelerated through an electromagnet. It is accelerated through an electromagnet, and your molecular ions will take an circular path. It has an circular path, that is they are deflected. So once they are deflected, it takes the circular path and it reaches the detector, and it is going to reach the detector. So when it is going to take this deflection because of this electromagnetic field, you will have a vacuum pump here. You will be having a vacuum pump here. So now this vacuum pump, it removes your free radical. This vacuum pump will remove your free radical, and only the molecules with the charged particles, with the charges, they will be falling on your detector. So ultimately after detector we have the amplifier. Followed by your recorder. So this recorder, it is going to record the mass to charge ratio against relative appendance, and you will be getting spectra here. So mass to charge ratio, depending upon the type of compound, you will have masses over here, and this relative appendance, it is normally calculated with respect to 100%. So the last peak which is appearing in this mass spectra, the last peak which is towards the right corner of this mass spectra, it denotes the molecular ion peak. Or parent ion peak. And the spectra which is having the highest relative appendance, you call that as the base peak. Okay, so this is a simple diagrammatic representation of the mass spectrophotometer. Okay, so I'll repeat once again. So mass spectroscopy or mass spectrophotometry, it is the most accurate method for determining the molecular mass of the compound along with its elemental composition. So how we are going to find out the molecular mass of a compound or its elemental composition? So we have a neutral molecule. This neutral molecule is bombarded with a beam of electron. So when it is bombarded with a beam of electron, this electron will it will remove one electron from this neutral molecule. Since one electron is removed from this neutral molecule, this becomes molecular ion M+, and one electron from an electron pair is removed, so it has a free radical. So that is denoted by this dot. So along with this, you will have the electron which is going to bombard this molecule and the electron which is removed from this molecule. Now this charge, when we are plotting this mass to charge ratio against how much amount of this M+ is formed, we get your mass spectra. So mass spectra is a plot between relative appendance and mass to charge ratio. So almost in all cases, for all elements, you have this charge as positive +1. So hence mass to charge ratio in many cases will be the molecular mass of your compound. So now this molecule, when it is hitting, when the molecule is hit by an electron beam, an electron is removed and results in the production of high energy, which causes here the molecular ion to go to the excited level. So this excited level is unstable one. It is an unstable one, hence it tends to return to the ground state by undergoing further fragmentation. So it either undergoes as M1 plus M2, M1 carrying the positive charge, M1 being the ion and M2 being the free radical, or M1 being the free radical and M2 being the molecular ion. That is M2 being the fragment ion. So you call this M1 and M2 as fragment ion. M1 plus and M2 plus, they are called as fragment ions, and the process is called as fragmentation. So only this M1 plus and M2 plus will be deducted by the detector, whereas these free radicals, they are removed outside the spectrophotometer by the vacuum pump. So how does an mass spectrophotometer looks like? So you'll have an inlet to introduce your vaporized sample, followed by the ionization chamber where the molecule neutral molecule is ionized, and it is through accelerators, it is accelerated towards the electromagnetic field. So because of the presence of this electromagnetic field, a deflection in the ionic path, in the path of your ions occurs, and they take a circular path. So when they take a circular path, your free radical will also be coming along with this ion, whereas by this vacuum pump which is present over here, these neutral molecules, these free radicals are removed off. Only the molecules with the charges will be falling on the detector, and it is amplified and finally recorded, which gives you a mass spectrum. So mass spectrum is a plot between percentage relative abundance against mass to charge ratio. So you'll be having mass over here and 100% relative abundance, that is how much amount of particular ion is formed there, will be present in the y-axis. So the last peak, which is towards the right hand side, extreme right side, it is called as the molecular ion peak or the parent ion peak, and the peak which is having the highest or the maximum relative abundance is called the base peak. So this is the basic principle and basic instrumentation of mass spectrophotometry. Okay.